Assalamualaikum warahmatullahi wabarakatuh. Good morning, good afternoon, and good evening. In according with the time you watch my video, introduce my face, guys. My name is Kamalullah Nur Fauzi. You can call me Kama, Kamal, or Kam Fauzi. Up to you. I am from Karangkates. You know Karangkates? Karangkates is small village in Malang district. I am 19. I just had a birthday. Maybe some of you want to give me a gift. This is my first video. I'm sorry if the quality of English production is not right. I made this video for Living Course Assignment English for Physics. That's University of Malang. And name leader me is Mr. Nurul Hidayat. I'm from Offering B Physics Education 2019. We'll discuss spring mass system. This assignment will be one to the values for English for Physics. No need will to make small tasks anymore. Let's start explains. I hope you guys are not bored. Let's go. Okay guys, let's discuss the spring mass system. You know the spring mass system? The spring mass system is a system composite of the object which has mass and is connected with its spring. The spring circuit can be arranged from several springs which are installed in series or parallel or series. The springs that are installed in series will decrease the value of the constant speed. Will spring installed in parallel will increase the value of the constant spring. Will oscillation is a periodic variation in the time of measurement ratio. For example, in a pendulum swing, the term vibration or vibration is often used as a synonym for oscillation. When talk vibration actually refer to specific type of oscillation, named mechanical oscillation. The relationship between the spring system and oscillation can be seen in the Hooke's law. Let's go. Hooke's law. The simplest oscillation occurs when the restoring force is directly proportional to displacement. The name that was given to this relationship between force and displacement is Hooke's law. F equal K times X. Here F is the restoring force, X is the displacement from equilibrium or deformation, and K is constant related to the difficulty in deforming the system. Often called the spring constant or force constant. Remember that the minus sign indicated the restoring force is in direction opposite to the displacement. The force constant K is related to the rigidity of a system. The larger force constant, the greater the restoring force and the stiffer the system. The unit of K are Newton per meter. Example, K is directly related to Young modulus when we stretch a string. A typical physics laboratory exercise is to measure restoring forces created by spring, determine if they follow Hooke's law, and calculate their force constant if they do. Mass on a spring. A common example of an object oscillating back and forth according to restoring force directly proportional to the displacement from equilibrium is the case of a mass on the end of an ideal spring, where ideal means that no messy world variable interfere with the imagined outcome. The motion of a mass on a spring can be described as simple harmonic motion, SHM. the name given the oscillatory motion for a system where the net force can be described by Hooke's law. We can now determine how to calculate the period and frequency of an oscillating mass on the end of an ideal spring. The period T can be calculated knowing only the mass m and the force constant K. T equal 2 times pi times square root m over K when dealing with f equal 1 over T. The frequency is given by f equal 1 over 2 times pi times square root of K over m. We can understand the debasement of this equation on m and K into value. If one more to increase the mass on an oscillation spring system with a given K, the increased mass will provide more inertia, causing the acceleration due to the restoring force F to decrease. This will lengthen the oscillation period and decrease the frequency. In contrast, increasing the force constant K will increase the restoring force according to Hooke's law. In turn, causing the acceleration at its displacement point to also increase. The reduce the period and increase the frequency. The maximum displacement from equilibrium is known as the amplitude X. You can show the picture at this. Thank you for watching my video. Sorry and wassalamualaikum warahmatullahi wabarakatuh.